GED questions often test more than calculation. They may ask which number is greatest, whether one value is a factor of another, or which common multiple solves a scheduling problem. These tasks depend on recognizing relationships between numbers. In this lesson, you will compare positive and negative values, identify factors and multiples, use divisibility rules, and apply prime factorization efficiently. To compare 58, 421, and 58, 317, begin at the left. The 10,000s and thousands digits match. At the hundreds place, 4 is greater than 3, so 58, 421 is larger. Do not compare numbers by looking only at their final digits. Place value decides the comparison. When values are close, a number line or a line notation can make the difference clearer. Negative comparisons often cause avoidable mistakes. -3 is greater than -8 because -3 lies farther right on the number line. Think of temperature or debt. Owing $3 is better than owing 8. A larger absolute value does not always mean a larger number. With negatives, the value closer to 0 is the greater value. To compare 3/4 and 5/8, convert 3/4 to 6/8. 6/8 is greater than 5/8. You can also convert both fractions to decimals or use cross products. Multiply 3 by 8 and 5 by 4. Since 24 is greater than 20, 3/4 is greater. Choose the method that is fastest and least likely to create arithmetic errors. The factors of 12 are 1, 2, 3, 4, 6, and 12. Each can divide 12 with no remainder. Factors usually appear in problems involving equal groups, rectangular arrangements, or simplifying fractions. A number has a limited set of positive factors. Factor pairs can be listed systematically by starting with 1 times the number and checking upward. Multiples of 6 include 6, 12, 18, 24, and so on. Unlike factors, multiples continue without end. Multiples appear in repeating schedules, package sizes, and common denominator questions. If one bus arrives every 6 minutes and another every 8 minutes, the first shared arrival after the start occurs at the least common multiple of 6 and 8. To find the greatest common factor of 18 and 24, list factors or use prime factorization. 18 has factors 1, 2, 3, 6, 9, and 18. 24 has 1, 2, 3, 4, 6, 8, 12, and 24. The largest shared factor is 6. The GCF helps simplify fractions and divide items into the largest equal groups. Multiples of 4 are 4, 8, 12, 16, and 20. Multiples of 6 are 6, 12, 18, and 24. The first shared value is 12, so the least common multiple is 12. The LCM is useful when events repeat at different intervals, or when fractions need the smallest convenient common denominator. A number is divisible by 2 if its last digit is even. It is divisible by 3 if the sum of its digits is divisible by 3. Divisibility by 5 requires a final 0 or 5. Divisibility by 9 uses the digit sum rule for 9, and divisibility by 10 requires a final 0. These rules speed up factoring and answer elimination. 2, 3, 5, 7, and 11 are prime because their only positive factors are 1 and themselves. 12 is composite because it has several factors. The number 1 is neither prime nor composite. Recognizing primes matters because every composite number can be broken into a unique product of prime factors, which helps with GCF, LCM, and fraction simplification. To factor 60, divide by small primes. 60 equals 2 times 30, then 2 times 15, then 3 times 5. So 60 equals 2 squared times 3 times 5. Prime factorization makes shared factors visible. For a GCF, use shared primes with the lowest exponent. For an LCM, use every required prime with the highest exponent. When a problem asks which value is larger, compare by position or common form. When it asks for equal grouping, think factors and GCF. When it asks when repeating events meet, think multiples and LCM. Use divisibility rules to work faster, but always connect the number relationship to the situation. The correct calculation must answer the practical question, not merely produce a valid number.